The second thing that we really recognized is that while we started off in late 2003, early 2004 with microvellum, the original kind of motto was, what do you want to build today? However, people that are generally in this kind of business are not necessarily thinking from spreadsheet to get to drawing. They think about drawing an aspect and how it's going to be as a result of it. And so we wanted to be able to create an environment that was very much free-form, a lot like what you'd have from a solid modeling kind of an application, to where you could build non-library items, custom cabinetry or whatever it is, without having to spend much time, and it to be very visual. And ultimately then we carried it on to being able to do that with full parametrics without having to really write any of the kind of complex Excel type formulas. And then of course the final is, we always loved the presentation of being able to show that we could do diewalls and stuff, but I think when you see what I do this morning, not only will you recognize that this can handle your production needs for it, but it also will probably emphasize why the strategy that microvellum took failed in the marketplace with so much of their customer base. So anyway, I hope that'll be good, and we'll kind of get started here with the creation of some things. If you'll notice, there's a variety of menus across the top. I'm on the rooms category, and I'll just tell it that what I want to actually do in this case is to be able to insert a wall, so you just select it. And of course, like you might expect, we could have preformed shapes, being able to select an existing polyline, or in this case, I'll just do a free construction to where it's going to allow me to just pick a place in AutoCAD that I want to use as a snap or a starting point. And so from the point of clicking that, then of course, I would be able to type in distances that I might want. For example, I'll type in that I want to be at 120 inches, and it will continue the wall command as many times as you want to move it. In this case, I'll say 144, and I'll hit enter twice, which will tell it that the command is going to be over. This, one of the things that we also wanted to do, recognizing that it might be a significant portion of our customer base that wanted to be able to move away from older kind of technology, and or users coming from one company where they had experience with it, we wanted to bring some of the things that were common to microvellum, the things that we liked into it. And so you'll notice that we've built very much the same kind of library structure to it, to where you can click down and to be able to get to products you want. If you just click on them, of course, then you can select the wall or whatever it is that you want to be attached to. One thing that I thought was nice is not only did we provide a way for an object to be able to slide along a wall, it's very smart in the fact that if I move to another wall, it changes all the orientation or rotation, so that makes it super fast to be able to work with. So anyway, I'll just select a position for it and tell it I want to build multiple of the same product here for a moment. And so to place a second object, you can just select on anything within the drawing. And so here you'll notice that I could place it to the left, in front, behind, above, below, or in this case to the right. So it gives you a huge amount of flexibility as to how you might want to place cabinets. Let's just look at another category. And in this case, I'll just select the product and tell it that we want to go on the right-hand side of it. And maybe let's get one more little category of something here and say I want to put a two-door upper in. I want to work with my wall. I can control the heights of everything. You'll see automatic dimensions happening for where you want it to go, and I'll place that product. Just so that we can see from the other wall, just so we'll have some return data in the drawing I want to take and say I want to put this guy in, I want to drop it over here. Now here's where the orientation makes a difference. I literally can, on the fly, affect where it's going to be positioned. So in this case, it'd make a lot more sense if its origin was the bottom right. I'll stick a couple of these in real quick.
That was always a big sticking point for me for microvellum.
Yeah, exactly. And so it literally can float on the fly. I mean, literally any of those points at any second. One of the other things that we wanted to be able to do is make working with work surfaces really smart. So there's only a couple of products, but it could have been as many as you wanted, and you click it, and of course then it's going to build countertops and stuff around it. One of the things that we're also started facing in the market, the more we were selling, was people having less skills at being able to use AutoCAD. So we created some tools to make it so that even people that are reasonably novice with AutoCAD could be able to generate fabulous architectural submittals. So I literally click a button, and I'm now generating 2D views. So it's It's working as what I'll really call 5D. We came up with that term for microvellum, but technically they just never accomplished what we needed there. I'm going to back off where I'm cutting this section or making the elevation of this, so it's going to be looking at the return of that other cabinet. It's wherever you have that pointed as to where it's going to do the slice for it. So now we'll see that I'm actually getting in my drawing what I want. As you know, because I believe you do have some microvellum experience, when you wanted to do things like cross sections and that kind of stuff, it was very much limited to the 2D draw tokens within the CutX file. Here I have a free-form ability to where I can cut it wherever I want, and I can look at it on either side of the line, and so that works out good. I'll label it as A, and we'll tell this that we want to be able to have this section. I'm going to go ahead and update this section and tell it that I want to add other components to it, and I'm going to tell this in this case that I want to be able to add the wall form in this case, so now we have that done as well. So if you get this, I could have made sections from any kind of directions I want. I want to make one more because this was also, to me, a frustration point with microvellum, that if I wanted to be able to get a plan section, I'll tell this I want to look from above, and I'll label this as B, that I literally had no way to do it because it couldn't think across multiple products. It could only deal with one at a time in that kind of a way. So that works out kind of nice. There's a lot more things that we can do. For example, if I wanted to annotate articles, for example, I want to add, maybe item numbers, positions, that kind of stuff to it, or, parts, that kind of stuff. I want to say, hey, I want to label my, shelves or whatever. I'll tell this that I want to do so, boom. And so now I've made call-outs, and of course there's lots of effects we can do. Might also want to be able to say that I want to auto-generate all of the dimensioning, for this. So I want to label the elevation plan, or I want to dimension those, and also my sections all created up nicely. I can go in that I want to be able to
specify which dimensions or how the dimensions appear, like if you want to change which elements they're snapped to?
Yeah, absolutely. So you've got control over those things, and if you'll notice that one of the things that's kind of cool here is before calling this function, please activate a viewport. Oh, new button that they gave me that I didn't know. It makes sense. I needed to do that. But in this case, literally being able to just work within this super fast to be able to get drawings and orientations and stuff, done in ways that, might not have been super easy for somebody that was not highly familiar with how to be able to work within the AutoCAD environment. So it makes it, what I would consider to be a, pretty amazing, flexible, product that we could be helping people get out the kinds of. I don't know how that resounded with you relative to what it is, but of course your dimension styles, line types, annotations, all that kind of title blocks, all that kind of stuff would be all yours. If we went in and
use
looked,
traditional AutoCAD commands?
Oh yeah, absolutely, absolutely. And what we'll notice is if we're working at a kind of visualization level, you get some kind of stuff, but in the work of this, it's also able to be able to take and to be able to move this up so that I could literally be seeing the quality of, the edge band drawn by itself. All these kinds of things can be pretty amazing. Let me flip this over and let you see it this way now that I turned the visuals up on this. So now, if you'll notice, I'm even down to the point of literally drawing the edge band. So they're actually separate objects, can be separate colors, all that kind of stuff. And so it really is a super, super powerful program. Of course, you could change anything that you want about anything, but one of the things that I wanted us to understand is that this is not using a spreadsheet with a draw token, so it doesn't matter whether it was something I pulled from the library or something that I created literally on the fly. I'm able to get the same kind of drawings out of it, and that was a real problem in working with within the microvellum family of products. One of the other things that almost always happened is people would be able to work from the library, but they'd get something custom that they needed to work with, and trying to get those in the same drawing, or even having the time to do it in microvellum so often that they would do it outside of the system. But I wanted to give you a quick example of if I needed to build a custom cabinet literally from absolutely nothing. There's nothing to it, and I want to build this thing from scratch. I could literally give it some size, for example, tell it 50 high, and we'll tell this 36, and I'll tell this 23.5, for example. I just built a cube that gives me a visual. I literally could then, literally like click on any one of these and you see what surfaces I'm dealing with. If I double click it, it would make a choice for me. In this case, I have both full tops as well as adjustable, or as stretchers. So we'll put a bottom in it, a left in it, a right in it. I'll leave the front empty, and I'll put a back in it. And I'll say, now, I might want to be able to divide this thing up. And first, I'll divide it vertically. And so I'm going to tell this that I want to divide it with fixed shells. And so if I did something as simple as put in 1:1, it would know parametrically that as that cabinet grew or shrunk in height, that it would always place it in the middle. I would also have the ability to put into it real numbers, such as 24:1 would tell it that 24 inches from the bottom is always where it's going to stay fixed, so it float from the top. Or again, simple things like 1:24 IN, and it would be floating so that it would be locked from the top. So there's a lot of cool things that you can do with very basic kind of formulas, and each one knows how to work within itself. I just gave it a 1:1:1 so that these would be always staying central to each other. I could then visually be able to work within an area. For example, I want to come down to this bottom area and tell it that I want to build drawers into it. I could come into this area and tell it now that I want to divide it horizontally and that I want to be able to add a partition to it. Here I'll kind of use an example that I'll make this fixed at 12 IN and 1, and so then I could, of course, drill directly into it, and I want to add a door to it, and I'm going to tell it that I want it to be hinged on the left-hand side. I'll drill into this area, and again, I want to do it with shells, but this time adjustable shells, and I'll just tell it that I only want a quantity of one of those. And so in a few clicks, by the way, if I said yes, I could save this to my library, give it a name, description, whatever, but I don't even have to save it to be able to utilize it. And so you'll see now that we have this product available within this project, and I'll go ahead and let it draw for what it's doing here. And so I'll tell this to regen. And so now we've got all those things done. Here's what's really cool about it. If I wanted to select this object and say, hey, I want to do something different, you'll notice that I built this thing to be completely parametric. So, for example, I want this thing to be 42 inches wide. That's what it becomes. I want to be able to, affect its height or whatever. I mean, all of these things, I'll make that 72.25. I mean, it's just ready to become whatever it is that you want on the fly. And I'll have to tell you, when I saw this the first time, I mean, it just was like voodoo to me. I mean, because I knew what it would take for me to actually generate that product and make it fully parametric and microvellum would have been a huge amount of work. Some of the other things that I think are really important here is to realize the flexibility that you have even working inside of a product at subassembly part and edge level. For example, if I said I want to go select this edge and this edge, sorry, I had a key pushed on there, so it had a backslash, so it wasn't allowing me to select anything. So I could literally select these edges in this case, and I'm going to say that I want to change the type of joint. And what if I told this that I wanted it to be mitered? You'll see that it's getting ready to do that. Or in this case, just to show you how smart it is, I'm going to tell it that I want the top to be onset. So we'll notice on the right-hand side and the left, it was an inset top. I'm now going to make the top onset on the left-hand side of this. And notice that just by clicking that button, it's even going to change all of the machining properties and everything on the fly. But I could continue to even being able to work with that. I'll just say that, hey, I want to be able to move that particular object, and I'm going to tell this that I want it to extend 1.5 inches, and so that's what it did. And so that made it really easy to work with. I could also be working in this with this 3D model easily, and I'm just going to use an AutoCAD command here because you asked a while ago, and I'll just say, hey, I want to make a circle, and I'm going to tell this that I want its diameter to be, in this case, 5 inches. Got some kind of a hole or something that I need to be able to do a cut through or whatever. I'll just flip this into a view to where we might see it, and I'm going to say that I want to be able to select some parts. For example, I want to take this part, this part, this part, and this part only, and I want to be able to apply to them an AutoCAD element, and I'm going to tell this that I want to make this circle that's going to work for all these, and I can control depths and all that kind of stuff. And so literally without having to leave this environment. I've done all of the machining that's required for manufacturing so that maybe I had some chase or pipe or some kind of thing that I needed to work with. Does that make sense?
Completely, yeah.
Yeah.
Yeah, I mean,
Can you go faster, though?
I'm sorry, say
I
again.
feel like you're going slow.
I am going slow, but just so that I can talk my way through it. Of course, if I was actually doing this, we could do it a little faster.
How would you add a toe kick to the cabinet? Can you do that too?
Yeah, absolutely. And if you'll notice that we've already done some of those kind of things, if we're working within the variables that we have for this, we can make it so that it's automatically smart to do those things. And I could be looking at this at either job level or article level kind of stuff. And so here you could affect, just like you would be familiar with, the material files. And so here you can select all of the, here's from the specification group. And by the way, you can have multiples of those. What kind of materials do we want to have and choose for these kinds of objects? But it's not only the materials. You'll also see that within the same environment, it would be like the global variables that you'd be dealing with, so that, for example, I could come over and say, hey, I want to change the joint type, and I want to go to dowels or full tops or screws and fetos and all that kind of stuff literally on the fly. Or, as you were asking, if I wanted to come into this and say that I want to get to toe kick, kind of construction for it, what do we want to do? We want to extend it, with a toe notch. We want to use leg levelers, separate base assemblies. All that kind of stuff is available to you.
That's sweet.
So now you're just modifying the drawing that we're in now, not the library.
Yeah, if I wanted to modify the library for the default values, I would change it in this field, and then I would save that and give it a name. The cool thing is, you know how you could have multiple specification groups in Microvellum? Well, you can have an unlimited quantity of those that is literally both the materials and construction together. And so literally you can just say open, go select the one that you've pre-built, and it's just a little dinky file, and it's going to work with whatever the library is, built for. And so I think that the strategy is so much nicer than all of the separate spreadsheets and ways that those things work. It's all internal into a really smart program. I mean, this is really how I would describe it. I didn't know it at the time when we were dealing with Microvellum, but after looking back at what this program inherently does, it's like Microvellum was this little dinky program with this huge amount of user load data that you were responsible for to make the program work. Here, it's small superficial bits of information that drive it. For example, if I took you under the hood for a quick second and just said, hey, I want to go look at program data. I want to go to Home Ag Solutions. I want to go to the library, and I wanted to look at descript files. For example, you might be wondering, how did I know how that I was going to, do machining and stuff? So, for example, now that one's pretty simple. They're just a simple script file that's working with it. So let's see what this one. Yeah. So now we can say that it's looking to say, hey, if this thing and its width is going to be less than 2 inches, then put it down in this way. If it's between this and this dimension, do this. These kind of things. So you can literally very easily control and be able to change construction methodologies by being able to determine which of those that you want for each part type on the fly. Instead of it having all of these extended formulas to do things, you can just literally have, like, if you notice, I had multiple top conditions. So in one case, I could be throwing in stretchers. In the next case, full tops. I could have the same kind of thing happening with dados, literally any kind of controls that you want. And these things were all nice and good until I showed them what it was that we really wanted to do to make custom, diewalls, nurses stations, cash reps. That kind of stuff really happened. Do you guys do a little bit of that work?
Yeah, we do.
We do, sure.
Nice. Let me give you a quick example of that, and then we can go into whatever kind of questions that you might have. Let's just this should be fine. Let's work from a top view. This would be better to show. Sometimes when you're demonstrating software, you don't necessarily run it the way that you would if you were using it yourself. You do that so that you're not changing the displays and those kind of things too much. What I'm going to tell it is I want to create an object designer article, and I'm going to tell this that I want to build a side view segment. So this would be very much like thinking about how I would literally construct this in the shop. And I'm thinking about, let's do something at least reasonably complex. I mean, still basic, but whatever. let's tell this I want to start working with the inside of this, and so I'm going to tell it I want to make a segment at 34 inches, and I want to be able to continue to add some segments to this. In this case, I'm going to tell this that I want to make a segment at a couple of inches, and I want to make another segment, and in this case, I want this, because of 3/4, 3/4, 1 1/2, I'm going to tell this that I want it to be at 3 inches. And the reason I was thinking about this was from the inside of this, that I wanted to be able to have a place for, in this case, for, how do I say this, maybe a countertop to be able to fit into something like that. So we're going to get a nice reveal for it. So I'm going to tell this the dimension that I want this to be able to work. And we'll continue to add a couple more of these. I'm going to tell this that I want to work from the right side of, from the left side of this, and that I want this to go up another 10. And I'm just going to build another segment off of this, and we'll tell this that we want to go 8. And I'll build.
You're just doing a vertical section.
Yeah, that's what I'm doing, is designing a section real fast. And I'm just going to tell this 24, and we'll continue here for just a moment. Let's go into, and what I'm thinking about is on the flip side of this, where we might be working, let's imagine that we're going to have some kind of aluminum extrusion or something, so we're going to come down here at 7 inches, and we're going to build this guy, and we could even make this so that it didn't even have to follow same shape guidelines or whatever. So in this case, I'm going to tell this construct that I want to work this way, and I want to come down into a distance that I'm going to work with a, with some kind of a toe kick, something like that. So I'm going to tell this that I want this to be at 9 inches, and I'm going to build this from this side. This, obviously doesn't have to be exactly how you would do a build, but I think that you can get from it that you can design any kind of a segment that you want to be able to get. And so I'm going to finish this out. So now I have created the segments that I might want to have. It was a few clicks, but obviously I could have just created a polyline and followed around it. In this case, I'm just going to use an AutoCAD command called boundary. Got to wait for an autosave. And so I'll just pick what I want to be able to do. So now I created a boundary for this. Lots of tools for you to be able to turn things on and off. For example, I'm going to say, hey, I want to hide an element for a moment. So now you can see that I do have a complete polyline. Maybe I even want to adjust that. Let's move it like a 1/4 of an inch, because I'm going to want that, the router bit going around to work appropriately or be able to show elements, this kind of stuff. When I've created these segments, and by the way, these things can be pre-saved and stuff, I literally then could create any kind of an object. I'll tell this that I want it to go at 78. I'll tell it to go 80. I'll tell this to be arc. I'll tell it that I want to control Shawn draw. Sorry, I got some keys that are sticking on my keyboard. I could edit those, but it's just as fast for me to build that little polyline again. And by the way, that was just AutoCAD. That's not anything to do. Oh, that's my problem. My S command wasn't working. So now I just gave this some kind of radius shape here that I want to work with. I'm going to tell this that now I want to be able to make a top view segment. And so here's my line. I'm just going to tell this that I want to make this guy at 8 inches. And I'm going to select this, and I'm going to move this object, in this case at 3/4 of an inch, because that's what I used for my inside material, so that my stud would be in the right kind of position for this. I'll say that I want to be able to array this, and I'll tell this that I want to do it along this path. And so I could say, hey, I want to move this at, let's just choose 16 inches in this case, and so we'll say okay to this. I'll explode these so that I can work with them individually. Maybe I want to copy an object, for example. Maybe I want to add additional studs or place the position of where they might go. In this case, I'm going to place an extra stud here, and I'll just say that I want to take it from here. Maybe I've got a location that I want to be able to double up studs, whatever I need to do. So now, if I wanted to be able to work with this, I literally could say that that I want to make parts from 2 views. And so I'm going to say I want to take the stud, and I want to take all of the top view segments, and I'll get rid of this polyline from the selection, and I'll tell it to build all these. And so now I've built all of these studs that are going to be able to work with this. And I'll say I want to do this again, but now I want to take this and I want it to follow this path. And so now I'll do that and create an insertion point, and we'll go from here, and we're going to build and extrude all the parts and pieces that would be necessary to complete this, this object. And so now if we looked at it in a southwest view, we would see that we have all of these things done. But I want to continue to go a little bit further, because this is, I think, going to demonstrate some of the things that just weren't easy to accomplish in microvellum that are super easy. I just say I want to isolate these two parts, for example, the top plates. In real manufacturing, I would never want to build a diewall with that kind of a field joint, in it and stuff. That would just not be what I would choose. Even if it was a shop joint, that wouldn't be what I would choose. So I want to know that I can literally work down at this kind of a level of parts, and I want to be able to say, I'll take these and I want to join them together. They now became one part, and so we could turn this on a top view. Just so that you can see this, I'm just going to make a polyline. I didn't pay attention to the dimension that I'm making it, but obviously I would have, where I doubled up that stud, I would have wanted that to be my break point in this case, so I could literally say, hey, I want to take this guy now, and I want to come to my cutting principles, and I want to cut this along the polyline shape. And it didn't have to be straight. It could have been, like you say, any kind of shape that you might want to cut it. But now I've got these back into two objects that are, broken in this case. And of course, I'd want to move these studs appropriately for it. But the same kind of control, I can make sure my bottom plates break different than my top plates and skins and all those kind of things. So I really have a tool that I can take to manufacturing.
Now, how do we dado the ribs into the plates?
I'm just so that you know, I'm working on a method to make that automatic. In this case, if I were doing it, I would have made this polyline that we could see from here. I would have clicked the wrong one. I would have taken this polyline and I would have stretched it so that it would have went into the depth of this, what I wanted appropriately. It may not let me do, yeah, it will. I thought maybe it wouldn't. So, maybe I want that to go at, a quarter of an inch. Oops, I put 25 inches. So what I would have done, sorry, I'm going to try to make this look better this time. I would have selected this guy, and I would have said that I want that. And, you didn't have to use the boundary command, but I would have had it a certain depth. So when it brought it across, that these parts would have already been inside of, and then I can select the studs and plates that I want, and it will choose then a construction principle for that, and I could have one set up that would be called dado, and voila, we would have dadoed studs into our plates.
So it would do the subtraction in the solid at that point, or would just have the machining logic?
It would do actually the subtraction of the solid and give you the machining logic both.
Okay.
It would be called a cutting principle. So anyway, I'm sure there's a million other things that we could possibly talk about, but I at least wanted to, within a half an hour or something, get through enough things for you to hopefully be able to see this is a completely different kind of beast than microvellum is. Yes, there are things that are similar, to it in some ways, placing cabinets and some of those things, but there's just a lot more control and intelligence built into the program.
Can we see a parts list run on a elevation of casework?
Yeah, absolutely. So in this case, the only thing that I'm going to do is say that I want to be able to save this order as, and so I'm just going to call this a 1003 just for today's date. And I think Roger said you also had a CNC, so we'll go ahead and not only make a parts list for it, but we'll go ahead and generate the data that we need for manufacturing. And if I read Roger's notes correctly, that we might want to be able to see that we could do this. So in this case, what do I have for a point-to-point? This will work. I only have a certain number of CNCs loaded in it, but it's just a difference of flavor. So we'll see that we would be generating, in this case, not only the cut list information, the material procurement, including sheet stock, edge band, hardware buyouts, all that kind of stuff, but also then generating the automated files for the CNC at the same time. And so those things are done and complete, and so then obviously we could transfer all of that data out, pointed past wherever it is that we might want to go, and so that's been done for us as well. And so now, excuse me, now if we wanted to see that those were created, on where I output those, I'll show you real fast. Program data, I stuck them here, and I put them in. Factory and IM order, and I think we called this order 1002.
1003, wasn't it?
Did I make that 1102?
All the way at the top, I think it was 1003.
There it is. Yep, it was 1003. I did it so it was my date and stuff, so that I would have all that stuff. So I have all of the bit mapping images, the FMX. Here's the wiki venture, and these would be the NPR files that were created to run that machine. It's just a little bit different flavor of G-code and on it. And of course, then here's the button to be able to access reports and stuff that are created. And so you maybe want to look over and say, hey, I got some kind of for example, a parts list I want to view, and it will fire up the reporting engine, which you can customize, do whatever it is that you need with the reports. And so then you can see that, for example, here's a parts list, and I'll zoom this up a little bit, that not only has the the cabinet reference to what it is, but the materials, its description, its edges, its banding, even a drawing of it depicting graining and machining, barcoding. I know Roger said you weren't currently doing that, but if you did, then it could contain all the program stuff, and so this would go through and be done and sorted. It's just an example of how somebody might want a parts list, but there's lots of other things that you might want to see, manufacturing lists, for example. And so then we've sorted, in this particular case, a number of adjustable shelves and back panels and bottoms and their size and all that information for them. And then you're going to want as well, I'm assuring, some kind of
hardware list and stuff?
Yeah, something like that. And I'm not sure which one of these to select on, but give me just a second. And so, yeah, here's a materials list overall. Let me blow this. Let me blow it to there. And so we'll say, now we're dealing with the solid wood. Here's all the sheet stock kind of stuff that we would deal with. And so here's all the edging, the different edge band stuff, and then the hardware that would be involved in it as well. So all that stuff, of course, was built in immediately from the time we did it. Roger,
do you have a shipping ticket?
Say again, sir?
Do you have a shipping ticket?
Yeah, I saw that there was a output parts list. I saw that there was a loading list, which I'm guessing might be. And so here would be all of the items that were involved in this product, so I would call that a shipping list.
Yep.
Yeah.
The other thing Roger had mentioned is that we might want, I'm just going to change this to 1003A, and I'm going to say I want to do this again. He thought that possibly you would want to see what it might be like for the future if you guys moved into nested-based manufacturing. So I'll kind of take you through that path real fast. It'll just take a moment, and I'll tell this that I want this to flow out to Cutright in this case, which is a fabulous optimization and nesting technology. Man, I tell you what, the true shape nesting of it is just unbelievable. That was one of the things that even people that utilize microvome, you may not know this if you weren't doing nesting, but their algorithms were so horrible that people constantly were having to edit all these nests and stuff. And I mean, that ought to be something extremely rare, and with this it obviously is. So I'll just pop open Cutright in this case. And if you remember, I made that order 1003A, since I forgot the first time what I did. And I'm just going to tell this that I want to be able to import all of these parts, pieces, materials, this kind of stuff. So there's 1003A. And I'm going to tell this that I want to go ahead and import it in. And so now that I have all of this, I will click on the Optimize button, and I'm going to tell this, the kind of thing that I want to do. If I wanted, I could send some things to a saw and some things to a router. Wanted to do, in this case, I'm going to say go ahead and continue with this, and I'll say go ahead. It gave me a message that I didn't read. What it says, data not correct, material thickness is 0. Not sure how I have a deal, but anyway, we'll cancel here for just a second. Apologize for that. Boards list 1003A. What am I missing? Thickness someplace. I haven't actually had it do that, so I'm not sure what the heck I've just done.
Is it in your saved materials list and not in your project materials list? Like, are you calling out the...
I'm sure there's something, and I may not know the answer, because I would have expected that what would have happened would have been here, that I would have had something that didn't have a relative thickness to it to get it to run. I may have to have somebody help me and come back and do this for you again. Sorry about that.
That's right. Is it in your material library? One of those materials is defined as having a thickness of 0?
Yeah, it must be something like that. I'm not exactly sure which one, and that's actually, I'm going to hit that one more time and see if it tells me. That is not correct. Material thickness 37058. 37058. So I'm not sure how to get to that, but that's my boards list. I've just never had it happen, so nobody's ever taught me what I need to do to make that happen. Something definitely changed in the link. No, I don't see anything in there that doesn't have a thickness. So if you could bear with me, I apologize for doing that. I'll figure out what caused that, and then can show you that literally it was one more button, and all the patterns were done. The G code was created. I mean, labeling done. All that kind of stuff at one time.
All right.
Can you show them another job that you ran just to give them another flavor?
Yeah.
Nesting.
Yeah, I'm trusting that would be something that would work for us. Something that I've probably ran before. Shoot, I don't have any idea what would be a good one. Okay, I did that one not so long ago. So I'll say yes to all. And so now I have this, and I'm going to tell this, we're going to allow this to default at nest. And we'll say go ahead. Yeah, so it ran fine. So something I did, and I'm not sure what it was, but something didn't match up a material somewhere. And so now just basically, the management summary, you can look at dashboards, results, the output of it, the required parts, the off-all, and the actual scrap for it. You can see the full patterns and off-cut patterns used and all that stuff. So it's really got some fabulous tools to it. And then if you want to see nests and those kind of things, including if we came down and looked at it, where we have door drawers and that kind of stuff, it will perfect grain match and all that kind of stuff. So it really does just a super nice job to be able to do that. And of course then, you could go look at, any one of these and drill into what it's doing and work with it, and that works out great as well.
Can I ask you to send me, I don't know, PDFs, I guess, of all the associated reports with one just generic job so we can see the nesting images, the materials, the hardware, the shipping list, all that stuff in relation to a simple run of casework? Can you do that?
I think so.
That'd be great. I appreciate that.
No problem. And so you can, get down to working with individual parts, and you can modify nests and, whatever it is that you need to be able to do. It gives you all the kind of tools that you would expect to be able to do manufacturing as well. So anyway, that was kind of a preview through some of the things that I think are relevant. There's a ton more that this program can do, and it's it's amazing. That's about the way that I can label it.
What if you had some kind of specialty hardware that's got to fit into a wall or something? Could you add that in there?
Yeah, and so what they call that, let me see if I can get to it here. They call it, I got to figure out where that button is for it, but they're called SPP. Yeah, and so now what it would allow you to do is to even, like, let's say, like on the outside of this, that maybe we were going to have some kind of aluminum extrusion, that was going to need to be on the face of it. You could literally just create the shape of that, and it would also then be able to put it into the drawing and count it as hardware. Same kind of things with your own hinges, slides, specialty hardware, whatever you might have. But one thing's really nice about this program is the most popular by far engineering manufacturing tool in all of Europe and good portions of Asia. And so you know where all the hardware stuff was done. And so all of those manufacturers of hardware have built all their stuff in. So if you become a customer, you literally get to go shop out on the web and bring down whatever it is that you want that's already set up and running within the WCAG CAM environment. So that's a really powerful thing where there's tens of thousands of potential hardware objects.
What are you guys seeing in the difference of the learning curve between this and Microvellum? I mean, I can guess, but...
For being able to do the things that Microvellum can do, I think it's less. Being able to go way beyond what Microvellum can do effectively, it's deeper and there's more that you can accomplish, if that's a fair way to say it.
Sure.
Because I mean, there is only so much that's practical to do with Microvellum, and I think that these tools are way easier to do that. But there's going to be some things I'm sure of that are deep. This would be a good example. My technicians that were also my Microvellum technicians, got into this program. Now they had to learn it not only on a level of using it, but teaching it and those kind of things. And they were about 6 days into learning about it. And their biggest statement to me was, we just keep unlocking depths of possibilities within this program that are unbelievable. So it really is. You can take it and you can do some good stuff with it, but I think it's one of those that the more and the deeper you want to go, it doesn't run out of ceiling height.
Gotcha. Bill, do you have anything? I'm good.
No, I'm good. Yeah, I'm impressed.
Yeah, thank you very much. If you can follow up with those reports so we can kind of get our hands on them and start to get other people understanding what exactly we're looking at, that would be helpful for us.
Super. And by the way, these are just example reports that are, of course, modifiable or can create your own or whatever you need.
Understood.
Very good. Raj, anything else?
Nope. We'll get those to you. And by the way, I'm recording this. If technology allows me to, I'll upload it to YouTube and send you a link so you can show it to other people also.
That'd be great.
Sweet.
So the last time I tried to record it.
Nice to talk to you guys again.
Thanks a lot, Sean. I really appreciate your time.
No problem. Take care.